this problem, we're given a set of data that represents a college student's weight in pounds. His name is Drayle, and he weighed 200 pounds when he started, that times 0, and then 8 months later he weighed 240 pounds. The first question that we're asked is to find his average weight gain per month, the average rate of change, and the first question has us doing this from month 0 to month 4. Eventually, when we get our answer, we need to round it to 1 decimal place. So it's important for you to know that in mathematics, average rate of change in this context, when you have a discrete set of data, can be found by the traditional slope formula. I don't think you can necessarily have to start the problem using the slope formula. In fact, you probably have some intuition that in the first 4 months, he went from 200 pounds to 230 pounds, meaning that he gained 30 pounds. Don't need the slope formula for this. He definitely gained 30 pounds, but that didn't happen in a 1 month period, that happened in a 4 month period. So he gained 30 pounds per 4 months. And in mathematics, division is noted in place of the word per. So 30 pounds per 4 months can be written as 30 pounds over 4 months as a fraction. So the division bar can almost be thought of as the word per. So this simplifies down to be 7.5 pounds per month. So what happens when students use the slope formula, however, is they tend not to want to put the units in with the numbers. I think it's important to put the units in as early as possible, and I'll show you why. So if I use the slope formula, think of the first point as being my input is 0, my output's 200. So that's 0, 200 is my first point. And my second point would be what happened at the end of the interval, which is namely 4 months. And at 4 months he weighed 230 pounds. So if I was to use the slope formula, this is my x1, y1. This is my x2, y2. So simply plugging in, my y2 is 230. My y1 is the number 200. That's the first y value. And I'm supposed to subtract those two to find the difference in the y's. So I think this is the best place to write the units because you got these numbers right from the chart. The 200 and the 230 clearly are in pounds. So if you wait to the very end of the problem, the numbers change and you kind of lose sight of the units on the numbers. So my x2 minus x1 would be 4 minus 0. And we're basically getting exactly what we got down here, except we're using the mathematical definition for slope rather than just maybe some intuition. So it's important to know that the 4 minus 0 does have units. The 4 and the 0 are both in months. So even if you had no intuition how to do the problem, just knowing that average rate of change can be done by finding slope, you would have said 230 minus 200 gives you 30, and it's in pounds. 4 minus 0 is 4, and it's in months. So the slope formula gives you that he gained 30 pounds per 4 months, which I said before, 30 divided by 4 is 7.5. So you end up getting 7.5 pounds per month. So now the question, however, first asks just for the average rate of change, which is just the numerical value of the slope. So what they want us to do is type in 7.5 with no units whatsoever. Now to interpret the number, this is where you use the story in the correct unit. So Drake gained on average 7.5 something per something, and if you look at our answer, it was pounds. So type the word pounds in there and then tab over to the next field or click into the next field here, and it was 7.5 pounds per month. So if we're going to be finding the slope or the average rate of change with this problem, it's always going to be pounds per month, no matter what interval we choose. Now the next question has us doing the same thing, just using a different time interval, so I think I'm going to skip that part to keep the video short. But suffice it to say, from months 4 to months 8, here's 4, he weighed 230 pounds. At month 8, he weighed 240 pounds. So he gained 10 pounds in 4 months, and 10 pounds in 4 months, if you divide that out, 10 divided by 4 is 2.5. So he basically gained 2.5 pounds per month. So the 2.5 would go in here, and then on average you'd write 2.5 pounds per month. So I'm just going to skip that part because it's redundant. It's the exact same calculation we did before, just different numbers. If we go down, the next one is to determine the average weight gain for the entire school year. So again, this is redundant, except it just means the entire school year was from month 0 to month 8, I presume. And this again probably can be done in your head. He went from 200 pounds to 240, so he gained 40 pounds but that took 8 months. 40 pounds per 8 months is the same as 5 pounds per month. So we would say the average rate of change is 5. And then down here we would say, including the units, 5 pounds per month. The last question is a bit different. They don't ask for us to calculate the average rate of change. It says, do the data points in the table define a perfectly linear function? If something's perfectly linear, the definition of a line is something that has constant slope, meaning that every time x increases by the same amount, y would increase by the same amount. And this clearly is not perfectly linear. For example, the slope, one way to think of slope is the increase in your output for every unit increase in my input. And this data is perfect for that definition because my inputs are going up by ones. So since my inputs are going up by ones, for this to be perfectly linear, I need only find if the outputs are increasing the same amount each year, and they simply aren't. From 200 to 209 means he gained 9 pounds that first month. If this was perfectly linear, he'd gain 9 pounds again the next month, and he'd weigh 218, which clearly he's not. He's at 217. So the data went up 9, so the slope is 9 there. Remember, the slope is the amount of increase in the output for every unit increase in the input. And I had a unit increase in my input, my output went up by 9. So the slope is 9 between these first 2 points. Then if you look at this point and this point, it only goes up, 8 instead of 9, so it's not constant. If you continue on, the next month he did not gain the same amount again. He went up 9, then he went up 8, and then if you subtract 224 minus 217, that's 7 pounds the next month. Here it's 6 pounds the next month after that. So you could just calculate several differences here. The next month, from month 4 to month 5, he went from 235. He ended at 235, started at 230, so that's an increase of 5 pounds that month. So far nothing's been constant. Finally, from month 5, 6 to 7, you see a linear pattern. From month 5 to 6, he gained 2 pounds, and then from month 6 to 7, he gained 2 pounds. But then the pattern breaks. From month 7 to month 8, he only gained 1 pound. So the question is, do the data points define a perfect linear function? That was obviously no. The slope is not constant, is the correct answer. But then it says, during what time period does his weight gain perfectly linear? So given discrete data like this, we can just go with what we have. And like I said, he gained 9 pounds the first month, and then it wasn't 9 the next. It was never constant until we got to this interval right here. He gained 2 pounds this month, and he gained 2 pounds again the next month. So from month 5 to month 7, he had constant weight gain, 2 pounds per month there, and 2 pounds per month there. So they want us to say from week 5 to week 7.